All right, last class, you guys, we talked about this remainder theorem, and I wrote up here, and that's what somebody says, what do you mean by a linear function? Well, sometimes, what if I have a function that looks like this? Okay, if I graph this, what is the shape of this function?
That is a parabola.
Okay, how do you know it's a parabola?
It'd be x squared.
That's right, it's going to be x squared. Each of the factors, yes, no, you did, Kyle, that's exactly right.
That's what I said.
If I graphed just this right there, if I graph just this, Seamus, what is that a graph of? A line, very good. And if I graph just that, what is it a graph of?
A line.
A line. That's why these are called linear functions, because they're just each individual one of the factors is a line. Okay? That was the only purpose of that. Now, we talked about the remainder theorem. The remainder theorem,
Yeah, the remainder theorem.
it works like this. Remember how I did all the work, I divided by, and then I said that the remainder was 0. Or you can put 1 into the function and get a remainder of 0. So that's the quick way to do it. And then I had you do some problems. Okay, now we're going to talk.
But that way you only get the remainder. Don't
That-
you want the whole thing?
Yes, and that's what we're getting into today. You're right. When we do it this way, all we get is a remainder. Now, here's a question for you. Does this function right here have a remainder? Where does this function cross the x-axis? Right here.
2 and negative 6.
Okay, at 2 and negative 6. Whoops, 6. That's not even a 6. It's a curly 6. And it's right side up, so it goes like this, okay? Now, okay, if I divided this out and I divided it by negative 6, what would my remainder be?
I don't know.
I don't really know.
No, if I divided this by negative 6, I'd get 0, because that's where it crosses, right?
I don't know.
And if I divided this by 2, I'd get 0. Okay. If this divides in and it has 0 for a remainder, it is a factor of that. Okay? So what that means is,
I'm paying attention.
I'm just, Hannah, if you could, thank you. All right. The factor theorem is to determine whether the first polynomial is a factor of the second. All right.
Can we get another one of those, please?
No.
I want you to divide this into here. How do you, I want you guys to do it right now. Divide this in. How would you divide it in? What are your choices?
Synthetic or long?
And what would you rather do?
Synthetic.
Great. If I did synthetic, what would I put out here?
Negative 1. Why not? What?
Opposite. Okay? The first one? No, this is,
Oh, wait.
yep, I want to divide this into that, okay? Bring it down, multiply, bring it down, multiply, add down. Okay, so if my remainder is 0, that means that this goes into this function evenly. Just like, all right, let's say for instance I have 12. If I divide that by 4, I get 3 with no remainder, correct? If I divide 12 by 5, I get a remainder, correct? Okay, so when you divide and you get 0 for a remainder, then this is a factor of this. Does that make sense? Okay, what is left over, you guys? What is left over here? What is this coefficient on?
X squared.
Okay, good. That's x squared. Do I have an x term? No. And what is this?
1.
Plus 1. Okay, so what that tells me is that x cubed minus x squared plus x minus 1 equals x minus 1 times x squared plus 1. Does everybody see that? Okay? This went in there evenly. And this was left over, right here. That was left over. So that means that when you divide that by that and I get a 0, I can write this then as 2 factors. Okay? You can only do that if the remainder's what? 0. Has to be 0. Okay? Now, take a look at the second one. This is just, is it a factor or not a factor? So, divide this into there. Does it go in there evenly with the remainder of 0? Check it out right now. What am I going to put in my...
2. Negative.
Negative 2. Okay? So put it in there. Then you put in there 4, 9.
4, 9, 37.
All right.
Negative 3, negative 7.
That doesn't matter.
What do I get for a remainder?
Whoa.
3.
All right. So, does this go into this function evenly?
No.
No. So, what we know is 2 things. We know that x plus 2 is not a factor of this cubic, and the other thing that we can tell because of this, if I were to graph this function right here, it would not cross the x-axis at negative 2.
Okay.
This one over here, on the other hand, crosses the x-axis where? At 1. Very good. Okay? All right, does that make sense? All right. This right here, we're going to skip this for right now. Okay? So skip this for now. And let's move on to this part right down here. Okay? In your homework, they simply want a yes or a no on these up here.
Well, that's easy.
That's not too bad. You just have to divide it in.
So we have like a 50-50 chance of doing that.
That's true. All right, take a look at this. What did we just say? Because 1 worked out just fine here, and it went in evenly, this function crosses the x-axis at 1. It crosses there. So, where does this function right here cross the x-axis at? What are my zeros? What can you tell that they are?
Negative 2.
Looks like 1, negative.
Well, here's my thing.
1/3.
Okay, negative 2 looks like 1. And then what's this one? 1? And this one I can't tell, can I?
I say half.
Negative 1/3.
Okay, and it's maybe it's a fraction of something. And it's a negative fraction. We really don't know what it is. Okay? But are you pretty for sure that it crosses at negative 2 and 1?
Yeah.
Okay, then you know what we're going to do? Let's start with negative 2. Let's divide negative 2 into the function and see if we're correct.
Yeah, but what's that going to do?
Oh, it'll give us the leftover part.
Oh,
Oh, wait a minute, what am I doing?
Yeah, I was like, what-
Wait, Mrs. Cersei's kind of writing the whole thing here. Hang on.
Axis of
I know, not supposed to put those in, am I?
Negative 5.
All right.
Alright, let's go. Drop the 3. Times say that's negative 6. And that's a negative 2. And then drop right in
Yep,
there.
it does.
And then
Yep,
go
it
there.
does.
Ta-da.
Okay, now what that means, you guys, is that, okay, I'm going to move this over just a little so I have a little bit of room. It means that this function, 3x cubed plus 4x squared minus 5x minus 2 equals x plus 2 times, and what's the leftover part now? What's this leftover part? Got to go down in a power. So what is, it was a cubic, so now this
It'll be
is,
3x squared.
okay, so wait a minute. This is 3x squared,
Minus 2x.
yep,
Minus
minus 1. Okay, now, that's good. We're still, that's not what we call fully factored. So, I really don't feel like doing the AC method. I mean, I could, but didn't we say that we were pretty for sure that it crossed at another place?
Yeah, you
It
can
looks
check
like it
that.
crosses at 1.
So let's do 1. Let's divide 1 into the leftover stuff right here, okay? Not back in the original one, but in the leftover stuff.
Could you still do it back into the original though?
Well, if we do it back in the original one, we're not going to be any further along. So we're just going to go with the leftover stuff. Because we know that x plus 2 is a factor. And now we want to find the other 2. So, bring the 3 down.
Can you tell us how to equal?
Yep, go ahead, Carter.
Right, can you just explain what you do?
What I did again?
Like bring the 3 down, then.
Yes, you bring the 3 down, then you multiply 1 times 3,
And this 3.
and you put it here,
Add
and
it.
you always add down.
So it's
Okay? So then we have a positive 1,
1.
add down. This is a good thing that I'm left with a 0. That's my remainder, which means now what is my other factor? X what? Opposite. Okay? Okay. Negative 2 went in evenly. So I have x plus 2 as a factor. 1 went in the leftover stuff evenly. So that's x minus 1. What do I have left over?
3 and 1.
3 what?
Oh, geez.
3x plus 1. I have now fully factored that function. Does that make sense?
Wait, what about the other 0?